Hello, guys. Hello. So I hope everyone is doing fine. So let's get started with this talk. And okay, so we're here today to talk a little bit about what pattern matching is and what we can do with it using Ruby. And we're gonna try to understand why we're not spreadly using it so far. And yeah. Uh, you guys are gonna notice that it is pretty simple, and once you're familiar with the basics of pattern matching, you're gonna realize that it's at the same time very powerful in terms of making our source cleaner in different occasions. So let me introduce myself for the future reference. So, everyone here knows me, but considering this talk is being recorded, I believe a short introduction may help the next viewers in the future. So, my name is Wender, and I'm a minor in Ruby Science 2016. Even though, you guys can find me doing a little bit of Node.js. And to be honest, I'm doing a lot of Node.js currently. Uh, okay, let's start talking about what pattern matching is. And to do that, we'll make use of the official documentation from the Ruby core team. And this documentation gives us the following description. Basically, pattern matching is a feature introduced by Ruby 2.7. I believe it was in 2019. And it allows deep matching of structure values. So it will take the structure and bind the matched parts into local variables. Uh, we'll see that basically there are two different things we can do with pattern matching in Ruby. We can test values against some pattern, and as well we can extract variables from these patterns. And for Ruby's the strange people, it basically means that we're gonna have multiple assignment along with a great case in support. In my words, I describe it as the match. It's a way we can use to match pattern against values. So we have some text, we have some number, we have a class, an array, or a hash, and we can match this value, this text against some pattern we need to. So how we can do that? We're gonna find two different ways of using pattern matching in Ruby. We can use the keyword in, where we're gonna write an expression and we try to match a given pattern in this expression to receive a true or false value. Basically, it's what we're gonna find if we're using like Ruby 2.7. We're gonna find this in pattern, and we're gonna find a little different behavior from the Ruby 3.0, 3.1 actually. And the second way, we're gonna use this equals greater operator that we used to call the rash rocket operator in the old times of Ruby 1.9. And the difference between the in keyword and this operator is that you're gonna receive a success, or if the pattern doesn't match, an error is gonna be raised. So the main difference here, even though in Ruby 2.7 we're gonna receive an error if we try to use the in keyword, but this behavior changed from the newest version of Ruby. So my description is related to the newest version. So in Ruby 3.1, for example, if we try to use the in keyword to use pattern match, we're gonna receive true or false. And using the equals greater than operator, you're gonna receive a success or an error is gonna be raised. So you guys can assume from here on that in every example I'll show you guys, you could use both the in or equals greater than operator if you guys are dealing with Ruby 3.1, for example. Okay, let's take a look at this example where we're doing a standalone validation using the in keyword to match our entire hash against the ID pattern. And it basically means that, hey, if my hash has a key called ID, this pattern matches, and you can print true. Otherwise, we're gonna print false. We're gonna have, we have this hash, and we're gonna try to verify if into this hash we have a key called ID, and if that's true, we're gonna put true, otherwise false in this case. But in the second example, we're doing a similar operation. So, but now we're using the equals greater than operator. In this case, we're saying, hey, let's try to match this entire hash that we have, the H hash, with a pattern, including ID, name, and age keys. But at this time, we're gonna receive no matching pattern key error, because if you notice, our original hash doesn't contain a key called age. What makes our pattern doesn't match, and we're gonna receive an error. A very common use of the pattern matching in Ruby is to take some complex decision using the case in statement. That's very similar to case when, for those familiar with Ruby. So, but the difference is, by using the case in keyword, we're telling Ruby to use the pattern matching, and by doing that, we're gonna have a big difference between the case in and case when. That's basically the case in using pattern matching. Our case is going to be exhaustive. So what that means is, in a case when, if you don't have an else clause, your program won't fail. But if we're using the case in and pattern matching, and we have the same scenario and we don't have an else clause, once our program exhausts all the tests and we don't have a match, we're going to receive an error. That's like we have in this example. We don't have an else clause for the operation. So if the operation doesn't match create or update, we're going to receive a no matching pattern error using case in. If we use case when, we wouldn't receive this same error. So to define the difference between every pattern we can match against when dealing with pattern matching in Ruby, the core team describes them in those 6 bullet points that I'm showing you guys here. We're gonna go deeper and show some practical examples in the next slides, but it is equally important to mention the concepts. They defined these different patterns you can use when we're using pattern matching in Ruby as the value pattern, array pattern, find, hash pattern, the alternative, and the variable pattern. So you guys are gonna also notice that we had contact with a couple of these patterns already, but we're gonna go over each of them. Okay, this is the value pattern, and this is what we have when we're matching some value into a given pattern, exactly like we'd have using the triple equals operator. For those, again, familiar with Ruby, we have an operator that's the triple equals operator in Ruby. And I won't dig into the whole set of features behind the triple equals operator here, but have in mind that it performs equality for different types of objects, behavior differently depending on this type. So a short example could be, for example, a range in Ruby. When we're comparing a range using a triple equals operator in Ruby with a given, a single value, we're actually asking if this range contains this pattern I'm passing using the triple equals operator. It would be like we're using the includes question mark method in Ruby. And another example could be, for example, if we're trying to compare a given value if with a class type using triple equals operator, what's going on behind the scenes is actually the Ruby is using the is a question mark method, and that's the essence of the triple equals operator. Now, depending on different types we have, we're gonna have a different behavior for comparing things using this operator. And the value pattern in pattern matching is gonna use the same principle. So as we can see in our examples here, we can try to match different values. Like we can check if the string Ruby is match the another strings Ruby. We can match different numbers, 42 with 42. We can use a regex to match a string with patterns of this text. We can also match this value with its type. We're comparing here the string Ruby and trying to find if it's a string. The same for the integer that we're receiving here, false. And also, it's interesting because we can also use the pattern matching to match like against a lambda in Ruby. So what happens is the language is going to execute this lambda and use the return of it to compare with the value with you try to match, and this is the value pattern. So the array pattern is a little bit different because by default, we can only match the entire object. So as you can see here in our example, our first example, we're trying to compare this array 41, 42 with the other one 41, 42, and we receive true because it matches exactly the same items, the same order. And different from the second example that we have this 41, 42 when we're trying to match another array with only 41 and it doesn't match. But of course, we can handle, we can work around this, we can have this, we can say, hey, I don't care about the rest of the items. I just want to match the first item like we're doing here in our example. And we're trying to match the first item and asking if it's 41, and I don't care about the rest. I can use this rest operator to do this pattern matching here. Another interesting thing that we can do with the array pattern is that we can also compare the internal items of the array with different types, like we're doing here in our example. We're comparing for the one, trying to see if it's an integer, and another one is in string. And if we have a different object like a float number, we could pass it here. Also, we're actually comparing the internal items of the array and using pattern matching to do that and verify these internal items. Defined pattern is still, it's also interesting, but it's still an experimental feature in Ruby 3.1. But in essence, it behaves very similar to the array, with the difference that using the find pattern, we can check if a given object has any object that matches the pattern. So like in our first example here, we can try to match like, hey, this array contain any integer value or any string value inside it, into it, we can also use, different patterns to do that, but the same idea. Like we can use a regex to say, hey, there's any item into this array that has a DON pattern into its value, or again, an integer. And we can also, use the rest operator here to work around, the entire match, the comparing the entire array. You can also use the rest operator here. So we also have the hash pattern. So the hash pattern is one case that we had contact before in our previous slides, and the hash pattern matches symbol keys against patterns. And here we have a main difference when comparing to the array pattern, because now we can perform partial matching. Even if there are other keys in our hash, if our pattern can be found, it matches, like in our first example. So we have the ID key and we have the other key called name, and we're trying to match. We actually asking, hey, do you have an ID key on your internals? And it returns true. Also, we can use this hash pattern to match against the key and value. So the second example, we're asking if we have an ID key with the value 2, and we don't have it, so we're receiving false. We can also do the same for the type checking. In the third example, we have this ID key, and it must be an integer, and again, we also have this REST operator for the hash pattern. So in our last example here, we're matching the ID, asking if it's an integer, and we don't care about the rest. So we're gonna have this REST pattern, different from the array pattern now. As you guys notice, we have this double asterisk along with the new keyword to say, hey, I don't care about the hash. I'm just trying to match, the first item. Okay, the alternative pattern is also very interesting, and it is actually simple to understand and to talk about it. So it tells us that we can mix different patterns to compose a union of patterns against our value. So like in our first example, we're explicitly saying that we accept either John or Mary as acceptable values. That's you have this John into this array, and we're trying to match the first item and say, hey, this first item, maybe either John or Mary, and it's okay, it's acceptable values. We can also mix these different patterns using the hash pattern. So I wanted to show the difference for you guys, and now we have this created at that we say, hey, it can be an integer, and it can also be a string, and it's gonna be a set. Both of them is gonna be acceptable values. So last but not least, so we can use the pattern matching to bind matched values in local variables. In our first example here, for example, we're using pattern match to extract the first item of this array into a local variable called head. And at the same time, we're matching that the other items are both integer values. We're using this the array pattern matching, and at the same time, we're extracting the first value into a head local variable. Like we have, the REST operator, as we saw in the other slides. So we can use the REST operator, and we can use this variable pattern to match this and extract this into a local variable. Like in our example here, we have this extracting the head, and the rest of the items into the array, we're going to also extract them into another local variable called rest. That's what we're doing here. And we can also perform more complex operations, like we may have a hash, and into this hash we may have a nested hash, nested arrays. You can have a more complex structure to match against, and we can do that, and at the same time we can use the variable patterns to extract variables. Like in our example here is trying to extract the Ra's best friend, and we have this hash with this friends node that's an array. And what we're doing is, hey, let's look into this pattern, this hash. It should have a name, and into the friends collection, we're gonna get the first item of the array. We're gonna get the name of this node, and we're gonna extract this name into a best friend variable, local variable. And that's what we're doing. And again, we're using the rest operator because we don't care about the rest of the items. And yeah, we can also extract using the rest operator. We can also extract and using the hash pattern. We can extract the ID like we're doing here into a local variable, and the rest of the items we're going to extract in another different different local variable. That's something that I've been we can see, people doing a lot in the JavaScript community, using this strategy to extract key values from an object, and keep iterating over the rest of the items. Okay, guys, so I think this is one of the most important things I'd like to share about pattern matching. In our previous slides, when we used different patterns, we didn't mention that, but as you guys probably know, everything in Ruby is an object. And for things like in keyword or even the equals greater than operator work, it should invoke methods that are capable to deconstruct the structure and allow values to be compared. So these methods in pattern matching context are deconstruct and deconstruct keys. Okay, we can use pattern matching to against the objects we have in our project. Like we can compare the objects we have in our projects using pattern matching. But to do that, we're going to need to make our objects to implement either deconstruct or deconstruct keys method. To be more specific, array and find patterns are going to trigger the deconstruct method, while the hash pattern is going to try to find the deconstruct keys method. We have an example here that where we have this class address, and we're receiving in this street that's an instance variable, and we're implementing here the deconstruct keys because we need to implement something, some way to extract values from this object into comparable objects. Pattern matching doesn't know how to compare addresses, and we use these methods to teach pattern matching how to compare different objects. We could compare whatever instance of the address that we have. We're able to match using pattern matching against some pattern like we're doing here. We're trying to make sure it has a street into it. The same thing here, but now we're implementing the deconstruct method. So it's the same thing, but now we're preparing our class address to be compared using the array pattern or the find pattern that we saw in the other slides. We're subscribing this deconstruct overriding this deconstruct method and returning this street into an array, and then we can compare it using pattern matching if it's a string or against some regex. But unfortunately, even though there's a pull request opened in the Rails source in the Rails GitHub, there's a pull request opening to add support for this feature in Rails. Unfortunately, the core team doesn't have a consensus yet, and by the time I give this talk, Rails it is in version 7.043, I think, and it doesn't support their internal object to use along with pattern matching yet, because no Rails objects doesn't implement the construct or the construct keys yet. Okay, guys, so that's what I wanted to share with you guys today about the pattern matching. And my intention is to give you a short introduction about pattern match and how we can use it, and how it may how we can make our code better in different occasions using pattern matchings, mainly when we're dealing with arrays and we're dealing with hash comparisons, and it can be very powerful. And if you guys are using Ruby 2.7 or greater, don't hesitate to use this. If you're using the Ruby 2.7, you're gonna see some warnings regarding, hey, this is a experimental feature, but it's not true for Ruby 3. It's stable already, and only the find pattern is still experimental feature. But as you guys can see, it's a very powerful, and you can use it for different occasions. Yeah, that's it, guys. That's all I wanted to share with you, and thanks for everyone here that's watching this talk. And yeah, see you in the next occasion.